Hello. Good evening, everyone. So good to see all of you. Deepanvita, Asya. Oh, Chandan. I'm just going to call you Chandan. Yeah, Kusuri, Chandan, Lakshya, and me saying hello there. Milendra, Shidula, Deepu. Good evening to everybody. Hello. How you all doing today? We're going to start thermodynamics. This is what we're going to talk about. Process types, internal energy. Oh, yeah, and most importantly, what is the system, what is the surrounding, and the boundary that separates them. Everything is about the boundary. That's why there was that funky thumbnail to drive that point home. Anyway, so we are going to look at these things today. Uh, so I did not give you any homework at the end of the last session because, well, we have a new topic starting up, right? But if you have any doubts in states of matter, maybe leave it in the comments on the video itself and we'll figure it out. I'm great, Milendra. How are you doing? Thank you for asking. So, NCRT, as usual, your best friend. If you haven't started reading it already for thermodynamics, please padhiye. Yeah. These are topics we're going to cover from NCRTs. Specifically, what is the system surrounding, the different types of system, the state of a system, whatever this is, we'll talk about it. And lastly, internal energy as a state function. We'll, kind of just brush over the last point and we'll deal with heat and work in detail in the next one. So this first session is more of an introduction to everything. What is thermodynamics in general? Because I don't think this is something you've studied in the lower grades. I think most of other topics you would have done a little bit of here and there in 8th, 9th, 10th or whatever. Maybe you've done a little bit of heat in physics. But this whole concept of thermodynamics, of interchangeability of forms of energy, I think that's the first one. So pay attention to this. The prerequisites for this, you need to do gaseous state, okay, which was states of matter. This is what we did in the last few sessions. All right. So, yeah, thermodynamics, heat movement, etc., etc. The main idea is to study the different forms of energy and the way that they get transformed from one to the other. And this is something that people don't talk about, right? When you transform a form of energy from one to the other, there's always losses, okay? And in the real world, that is a big problem. What we are doing, we are assuming that there are no losses. Everything is hunky and dory. But in the real world, there are losses. Keep that in mind. Not a part of your syllabus or whatever, but something to just think about, right? So, yeah, energy and interconversion, that's our focus. Right now, for us at 11th and 12th grade, we're going to focus on thermodynamics at the bulk phenomena, which means the temperature of air around us or the volume of air and all that. We are not going to look at the individual molecules of air and study them. Yeah, so this is not microscopic stuff. We're going to look at macroscopic properties like temperature, pressure, and volume of a gas. So most of our discussions are going to be about gases. In physics, in 12th grade, you're going to look at thermodynamics also, but from a different perspective, right? Sayam, I would say that's awesome. Hey, Sagar, okay, that's good to know. लक्ष्य, आप तो मेरे बहुत सेशंस में आ चुके हैं. हम लोग जरूर बात करेंगे. Ouch, this, yeah, sorry. Yeah, I thought you follow everything. I switch between both, right? Hey Vaishnavi, hey, good evening. Sayam ji, I would say कि बहुत बढ़िया बात है. अभी से शुरू करिए, start off. This is a good time to start. I think 10th grade is the best time to start the whole JEE NEET prep. It's okay if you're doing it in 11th or 12th either. But 10th is like easy. क्योंकि 10th और 11th के बीच में jump बहुत ज़्यादा होता है. So for maths, I'd say do logs. For chemistry, I'd say do mole concept. And this, thermodynamics, read up a little bit. Biology के बारे में, ask Sneha ji and Ankita ji. They'll tell you a lot more about biology. Okay, great. I am speaking English, Vignesh. I'll speak in both. Don't worry. I'll make it a point that whoever's watching our lecture will be able to understand everything. Hey, good evening, Narendra. Good to see you. So, what's the point of studying thermodynamics, right? See, I keep repeating this. आप लोग मेरा videos देखें, whatever, but that's great. Please read NCRT because everything is going to come from NCRT. And what I'm teaching you is directly from NCRT. So anyway, why do you need to study thermodynamics? Well, the reason for a chemical reaction to happen, what is it? We have studied bonding, we have studied states of matter. मतलब कि process क्या है वो हमने पढ़ा है. But why does it happen? That's what we're going to talk about. And the energy changes involved in any chemical reaction. Do you remember this? When you form a bond, energy is released. To break a bond, you require energy. Keep that in mind, okay? This is a very important thing. हम लोग maybe we'll look at this again in the 3rd or the 4th session. Okay. This is very interesting. Points number 3 and 4, okay? Do reactions go to completion and can they be reversed? This we'll study in detail in equilibrium, which is the next chapter. But usse pehle, I'll set up some ground rules and some basis which is thermodynamics itself, which is related to how to predict if a reaction is going to happen or not energetically. अगर आप already 12th standard में है, then you've also looked at kinetics, which is the other side of the same coin. Ki, okay, maybe energy says it can happen, but in reality it just doesn't happen because kinetics doesn't favor it. इस सेशन में हम लोग, since it's the first session, I'm going a little slow. Yeah, from next one onwards, please read NCERT Income. We're going to do a lot of interesting questions, a lot of math. Okay. 9 months plan, Krishna. Okay. I mean, how do I make that for you? That's on you, my friend. I can guide you as a teacher. I'm your mentor. A plan is something you're going to have to make. Okay. You've seen a lot of people talking about plans. They tell you the best course of action. Hey, what's up, Fakir ji? Yes, ये chapter थोड़ा खतरनाक है. Good to see you, Fakir ji. Krishna, just diverting from what we're talking about right now. The way to do this is to make a weekly plan, and then expand that into a monthly plan. Expand that into a 9-month plan. That's what I'm doing at work as well. Like I know for a fact that I'm going to divide thermodynamics into 6 sessions. I know I'm going to do metallurgy in 4 sessions. I know I'm going to do stereoisomerism in 4 sessions. And so you see, I have decided how long I'm going to teach this for. Same thing you got to do. You got to work backwards. You got to, instead of teaching it, you're going to have to study it. Okay? I know I'm oversimplifying things, but that's the way to do it. You got to break it down. That's what all these books called Atomic Habits and all teach you. Care, we'll get back to thermodynamics now. Okay? Sure, man. I mean, you can do anything you like, but you're going to have to put in a lot of hard work if you're starting right now. I'm going to be straight with you. Okay, so what are the different terms we're going to talk about? System, surrounding, and boundary. Did you see that cool thumbnail, by the way? Did you see that cool thumbnail of this video? The reason why I made that was because of these 3 things. Students don't understand the basic ideas here, right? They are able to solve questions, but what is the system? What is the surrounding? They mug it, but let me talk about it a little bit, okay? So system is something that I'm focusing on. Like for me right now, the focus is going to be the gas, okay? So that's my system. What's the surrounding? Everything that's not the gas in question, okay? It's as simple as that. If you talk about a Venn diagram, it's basically system and everything else is surrounding, okay? That's what we're talking about. Now, how do you define a system then? मैंने अपने अब बोला कि देखो system gas है, but कौन सी gas? Where does it go? So for that you need something called a boundary, and boundary is exactly how it sounds. Like you have a boundary area on your house, you probably have a fence around it. It can be a real fence like that, or it could just be, as I said, the gas that's in this room. So there is no real boundary, but it could be imaginary. I just need to define it. In fact, I could also define a boundary to be, the shape of this balloon. That's what this was about, right? The thing, the jar ka shape जो मैंने बनाया था जिसमें हाथ रखा हुआ था. That is a boundary, right? The boundary could also move around a lot. Like when I inflate this balloon, then उसकी boundary बढ़ती जाती है. If I deflate it, it keeps getting smaller and smaller. It doesn't matter. The boundary just needs to be defined. It can be variable, it can be real, it can be imaginary. But the boundary is what defines the system and surrounding. Okay, we'll talk about this a bit. There's a bit of chat going on. Hey, Milendra, thanks. I will pass it on. There's an awesome artist called Sharvi that made this. Good to know. Hey, Naruto. Hey, Naruto. I kind of mixed up both your names. I'm great. How are you doing? Yeah, I'm in that sagar. Exactly. I'm in that glass. All right. Hey, Pranjal. All right, cool. So, I hope you understand what a boundary is. Yeah, this is extremely important from the theory point of view. So, because once you define the boundary, that okay, everything that's happening inside the boundary, that's my focus. So here is a more proper way of looking at this right on top of my head, right? What do you have here? This whole thing is basically my universe. This chap right here. System is what? Just this green stuff. Surrounding is what? Not this green stuff. Everything that's not this is the surrounding. Okay? So, clear, right? Any doubts so far? Is this all right? What we're doing here? System, surrounding, boundary and all that. This session is light. I'm telling you, the first sessions of every chapter are going to be light. We'll pick up a lot in the next one. But for now, I want you to focus on all of these things. Aram se samjho, theek se samjho. Okay, great, good to know. Now, in NCERT, we talk about different types of systems. Okay? Which is based on whether matter can or cannot be exchanged, or whether energy can or cannot be exchanged. Okay? So an open system, matlab ki, like this nice beverage brewing over here, is where both of these can be exchanged. यानी कि खुला हुआ है, right? It's open to the atmosphere. So both mass and energy can be exchanged. Okay. What does this mean? It means that the boundary lets that happen, right? So think about it like a boundary that's letting everything go through. Yeah. So it's the boundary that actually defines the system. I want you to understand this. A closed system is such that, बाउंड्री ऐसी हो गई कि मैंने पॉलिथीन बैग उठा लिया, पॉलिथीन के अंदर जो है वो अंदर ही रहेगा, वो बाहर नहीं जाएगा, which means that mass cannot be exchanged, but it can get hot, it can get cold. Oh, so the boundary, when it does not allow mass to pass, is called a closed system, but it allows energy to pass. Okay, now the third thing to talk about is ठीक है अब दोनों नहीं होगा. Now it takes such an awesome boundary, called, I'll talk about what that means, adiabatic boundary, just like this awesome flask that I have right over here, right? This flask is, and theoretically at least कि मतलब कि 12-13 घंटे तक पानी गर्म रखता है, right? So this is an adiabatic boundary, which means it does not let mass to pass through. Obviously, thank God पानी गिरा नहीं, that would be a funny thing to do, and गंदगी होती, and it doesn't allow heat to transfer as well. Okay, so the boundary is what defines a system and surrounding. Does everybody understand this? Yeah. So 3 types of systems based on the different kind of boundaries you have: open, closed, and isolated. Isolated का बहुत सिंपल एग्जाम्पल है थर्मस. क्लोज मतलब कि मैंने बंद कर दिया बट हीट एक्सचेंज हो सकती है. ओपन मतलब भाई कुछ भी हो सकता है. ठीक है. What do you mean by it's temporary, Milendra? See, everything we are doing is theoretical, so it could be permanent. Why not? Like the examples I've given you are real life examples, and the problem with real life examples is कि, well, they're not theoretical. I mean, sorry, they are, yeah, real life examples are not theoretical. मतलब वो तो actually हो रहे हैं. I told you in the starting. I knew people would ask me that question. Excellent question, Milendra. मैंने शुरुआत में ही सेशन के बोला था, देखो भाई, हम लोग जो कर रहे हैं वो assume करें ideal case. But in real life, when there is a change in energy, in transformation, there always are losses. So which is why there are losses, right? This is losing heat, and it's not a perfect system. Okay, I'll talk about adiabatic. Sridula, good point. It just means something जहाँ पे heat transfer नहीं हो सकती है. ठीक है? No heat transfer. Now, what is heat? What is work? We'll talk about towards the end of this. I have this habit of giving you spoilers. I would never do that for a TV show, but as a teacher, I have a habit of giving you guys spoilers. ठीक है? Sridula, hold on to that thought. Adiabatic, fancy word. We'll talk about that. Okay. So what is a closed system? Just checking if everyone is awake while we discuss this. A closed system can exchange with the surroundings heat, mass, heat and matter, or neither heat and matter. Okay. Milendra, Sridula are both saying A, and Milendra is sealing that with saying heat. Deepanvita is also saying A. Absolutely. Close मतलब बंद. बंद है तो mass बाहर नहीं जाएगा. Mass will not come in. Laksha, are you able to follow? You wanted me to speak in Hindi. मैं दोनों में बात कर रहा हूँ. Hey Rudraksh, what's up? What's up? Hello. Good to see you. You had asked me an amazing question on Langmuir isotherm, I think. Or no, you had asked me another question, which I actually answered last time. I missed you yesterday. On Friday, we were doing a question that you were talking about. You asked which of these particles does not depend on the charge, and the answer was Tyndall effect. वो मैंने पूछा था वो सवाल. Anyway, good to see you here. Hey Asya ji, Lakshya, Naruto, everyone saying A. Deepu as well. So yeah, the answer is definitely A, which is heat. Okay, how about another one? System and surrounding together constitute. ये तो बहुत आसान सवाल है. What is it? Is it universe? Is it the earth? Is it solar system? Oh man, this is such a funny question. Yeah. Universe, sure. Let's move on. Okay, just to make sure everyone's awake. No other reason to have this question here. Okay, so what is the state of a system? That's what we're going to talk about next. State is something that defines a system perfectly. Now, for a gas, since we've just done states of matter, gas laws and all that, you know that a gas can be defined perfectly when you know its pressure, volume, temperature and number of moles. ये चारों अगर मैं गैस के बारे में बात करूं, now our focus is almost entirely going to be gases for the first half of this topic of thermodynamics. In the second half, when we do some sort of calculations, when we do enthalpy calculations, उस समय हम focus करेंगे reactions पे. अभी we're going to talk about non-reacting gases. ये एक और चीज है जो कभी कभी स्टूडेंट्स भूल जाते हैं. थर्मोडायनेमिक्स के फर्स्ट पार्ट में when you are doing all of these things, when there are changes of process and all happening, it's all non-reacting gases. ठीक है. Little Earth sarcastic. Yeah, Little Earth. That sounds like a rapper. That'll be a cool rapper, right, Milendra? Arman, my qualifications. I have done bachelor's in engineering from RVC. Also went to Surat Karan ISC but didn't finish those degrees. Yeah, So basically, I've written GATE and AIEEE and JEE, if that's what you're asking me. The exams I've written, yeah. Okay, and cleared. State functions. What are state functions? Well, values. Just exactly as I said, depend only on the state or system. Matlab, this next line is funny. What is path now? Does not depend on the path by which the state has been attained. इसका क्या मतलब है? तो state तो हमारा volume, pressure, temperature और number of moles था. ये चारों चीज state define कर रही थी. अब path कहाँ से आई? What is this path business? Okay. A path is literally like, you're walking on a path. So there are different ways of achieving the same destination. Think about it like this. I can fly from here to, say, Delhi or to, say, Calcutta. I'm in Bangalore right now. Or I could go by train. They take different times, maybe different paths, but the end destination is the same. So the state is me being in Bangalore, me being in Delhi, but you have different paths. If you don't like this example, a simple example is, distance and, let me use a different color to show this, displacement, right? You've heard this in physics as well, distance and displacement. This is whatchamacallit, a state function, so to speak, displacement, and distance would be a path function, correct? Okay, irrespective of what path I take, the displacement is going to be the same, but the distance will keep changing. So a path function, it depends on the specific path you take. Now, even in this case, right, our path may not look like this in thermodynamics, but we'll talk about different paths just in a couple of minutes of time. Okay, we good? Yeah? All right. So the difference between state and path functions. State functions don't depend on the path. Path functions depend on the path. This is funny, but this will actually get you marks. Depend on the state functions, depends on how the state is actually achieved. So here are some examples of path functions. Interestingly, right now we're only going to look at heat and work. We're going to study this in detail. State functions, so many of them. Sab Maharathi ek saath. Internal energy, enthalpy, entropy, temperature, volume and pressure. Abhi isme se you know about temperature, volume and pressure. What on earth are these three things? That's what thermodynamics is all about. We'll briefly talk about this guy right here. Maybe in this session, we'll talk about this. And the others, enthalpy, entropy and all, in the next episode of Thermodynamics with Ashish Shekhar. Okay, so remember, everything we're talking about, macroscopic properties, which means we take a lot of gas and we talk about that. We don't talk about individual gas molecules. Okay, cool. But I can define macroscopic properties to be intensive, extensive. Do you know what these words mean? English words? Intense, extends, no, it's not that. Intensive means it's a property of the system itself, of the Okay, hold on. Let me think this through. I'll give you an example. It's better. Like, which of these properties will change when the given solution is transferred from the beaker to the test tube? Okay, extensive and intensive. That's what we're going to define with the help of this example. So tell me, okay, मैं इसको जो इसमें इतना weird green liquid है, मैं इसको चार अलग-अलग beakers में डाल रहा हूँ. Let me mark those beakers as 1, 2, 3, and 4. Now, which of these 4 properties would be the same in all 4? Or would it be different in all 4? So, what do you mean by C? Okay, you're saying density will change? I'm asking कि कौन सा change करे, कौन सा change नहीं करे. Will the concentration, let's go one by one. Will the concentration change or not अगर मैं ऐसे करूं? I'm transferring that amazingly well shaken up beaker into these 4 test tubes. Will the concentration change? Okay, Milendra and Shridula say no. And so does Deepanvita. So I'm going to mark this as no. What about number of moles? Does the number of moles change? Asiya is also saying no. Deepu is saying no. I'm guessing it's for the first one. We're talking about B right now. B, yes or no? Milendra says कि no as well. Deepanvita is saying no as well. अच्छा, दोस्तों, क्यों? Number of moles तो बदलेंगे? क्यों नहीं बदलेंगे? देखो, think about it. Maybe मेरे पास में 1000 मोल है, 100 मोल है, ठीक है. इसमें लगता है 5 मोल चले जाएंगे. लेकिन डिफरेंट कलर ताकि क्लियरली दिखे. कौन सा कलर यूज किया जाए जो जहाँ दिखेगा? हरा वाला यूज करते हैं. मे बी इसमें 5 गए, इसमें गए 10, इसमें गए 20, इसमें गए 3. आई नो दैट add up to 100, but say approximate numbers, right? So number of मोल तो बदलेंगे ना? Sure. But Shridula, what I'm asking is कि in 1, in 2, and 3, and 4, which properties will be same in all 4? Which property will be different in all 4? Maybe I did not phrase my question correctly, Shridula. Okay. Which of the following properties will change when the given solution is transferred from the beaker to the test tubes? मतलब I know what you're saying. Total number of moles, sure. सही बोला आपने श्रीदुला जी. Total number of moles same होंगे, but because मैंने different amount of substances लिए, इसलिए moles भी अलग होंगे. Correct? So ये property बदलेगी. What about density? So just like concentration, I think you're all convinced that density भी नहीं बदलेगी. Right? क्योंकि आपने अगर concentration बोला है नहीं बदलेगी तो density भी नहीं बदलेगी. Volume? Volume definitely बदलेगा. Volume तो बदलता हुआ दिख रहा है ना. सबसे obvious volume ही दिख रहा है. Right? Correct? Yeah? So, out of these, concentration does not change because interestingly, concentration is a ratio. Think about it. Concentration किसका ratio है? It's a ratio of mole by volume. Oh, that's interesting. You see that? दो properties, mole और volume, both of which change, but उसका ratio नहीं बदलता है. Similarly, density is what? It's mass by volume. And since mole बदले, तो clearly mass भी बदलेगा, but उनका ratio नहीं बदलता है. Keep this in mind. Okay. So, intensive properties can be defined as independent of the mass or the size of the system. Extensive property यानी कि something that's dependent on the mass of the or the size of the system. ठीक है? So, extensive मतलब अगर मैंने mass बदला किसी चीज का तो property बदल जाएगी. That is extensive. और अगर mass बदलने पे भी property नहीं बदली उसको हम लोग intensive बोल सकते हैं. Cool? Now let's take some properties. कौन सी बदलेगी नहीं बदलेगी. Temperature कहां पे डालूं मैं? Intensive or extensive? Just put I or E. How about this? Because you're going to talk about 4 or 5 of them. Put Ti or Te. Next वाला जो भी होगा, जो भी variable होगा, उसके साथ ये डाल दो. E, I, A, E, I, O, U. We are doing all of them. Shridula says I. There's one for I. Milendra says E. Okay. And Pranjal, Asya are all saying I. Dipanvita is saying TI. Great. Following instructions. Love that. Captain Lucky Bharadwaj. I love that name, Captain Lucky Bharadwaj. I have a good friend with the surname of Bharadwaj. I was just speaking with them this morning. Okay. All right. Yeah. So, yes, most of you have got this one right. Temperature is intensive. Why is it intensive? You remember states of matter में से हमने बोला था कि ये temperature of a gas depends on just the velocity of the aggregate of the particles. It doesn't depend on number of particles. आपको याद आ रहा है states of matter से? अगर वो याद नहीं भी आ रहा है तो ये भी देखो ना. अभी देखो इस AC का टेम्परेचर लिखा है 25 डिग्री जो आप शायद देख नहीं सकते हो. बट 25 डिग्री हर चीज का 25 डिग्री है ना. It doesn't matter how much of it is there. Cool. ठीक है? So this is intensive for sure. And a simple way to understand is कि if I take a big loaf of bread, उसका जो भी टेम्परेचर उसको काट के मैं निकाल दूँ तो वो भी सेम ही टेम्परेचर रहेगा. टेम्परेचर नॉट गोना चेंज. गैसेस में भी सेम चीज अप्लाई होता है. मे बी conceptualizing this to a gas is a little tricky कि अरे गैस कैसे करेंगे. But think about other particles. Intensive, extensive, you can talk about anything. Okay, next one. Volume. VI or VE. Intensive, extensive. ये वाला simple है. मैंने just अभी बताया था आप लोगों को I think. Okay, good. If it's simple, it's not a bad thing. It's a great thing. अगर आपको चीजें आसान लग रही है आप लोग कर पा रहे हो तो बहुत ही बड़ी चीज है. मिलेंद्र, कैप्टन लकी जी, आसिया जी, all saying Pranjal. Okay, the moment I have 5, I will move on. Medha is also saying 5. You're beautiful. All of you are so amazing. All of you are brilliant. ठीक है. This is definitely extensive. If you want me to explain anything, please let me know. Medha, Dipanvita, Deepu as well. अगला वाला pressure. ये interesting है. ये कहाँ जाएगा? Pressure is intensive या extensive? Do you need a hint? Okay. Captain says I. Narendra ji says E. Milendra says I. Shujula says E. Asya says I. We have a split vote. Hung assembly. कोई भी 5 वोट तक नहीं पहुंचा. और क्या चल रहा है? What's happening, guys? Medha says intensive. Deepu ने पल्ला भारी कर दिया और हो गए 5 हमारे पास. और दीपान्विता crosses the border. Yes. और दीपान्विता फिर से बोल रही है क्या? नहीं. I was right. Why are you retracting? Narendra also. Okay. So all of you are saying pressure is intensive. I'm going to put that here. Okay, so मतलब कि मे बी सही है, मे बी इंटेंसिव ही है. Deepanvita also saying intensive. Okay, people who said extensive, do you want to give me a debate as to why you think it is extensive? It'll be good to have your opinion. क्यों है extensive? देखिए, it's an interesting idea. If I change mass, pressure बदलेगा कि नहीं बदलेगा? सोच के बताइए. Think about it. I know this one's a little tricky, right? क्योंकि you may be thinking that अरे मैंने गैस ली, अगर गैस का मास कम हो गया तो फिर गैस ही कम हो जाएगी, तो गैस कम हो जाएगी तो फिर प्रेशर कैसे सेम हो सकता है? That's one way of thinking of it. The other way of thinking of it is कि पिस्टन है, इसमें गैस है, ठीक है, मैंने थोड़ा मास निकाल दिया, प्रेशर सेम कैसे होगा? पिस्टन नीचे चला जाएगा. अगर पिस्टन नीचे चला गया मतलब वॉल्यूम कम हो गया, ठीक है, प्रेशर इज सेम. Just a way of, for argument's sake, just hear me out. People who said extensive, I'm hoping the people who said intensive understood this. Are you guys convinced? The ones who said extensive, do you want me to just go up and check किन्होंने बोला था? Is this explanation sort of okay? The reason I'm saying this is most of the things that you are working with could be considered to be done under atmospheric pressure. Now if you're doing that and मैं मास कम कर रहा हूँ, the easiest thing will happen is कि ठीक है, वॉल्यूम कम हो जाएगा. That's it. अगर वॉल्यूम कम हो गया, प्रेशर नहीं बदलेगा. I could see how you would think कि अरे मास कम करने से प्रेशर कम हो सकता है, right? Because on the other hand, if you see कि PV equal to nRT, अगर मैंने वॉल्यूम फिक्स कर दिया, if I do that, then अगर प्रेशर कम होगा तो मतलब नंबर ऑफ मोल्स कम हो जाएंगे. This is something that happened when we were doing that gas to liquid. उल्टा किया मैंने, देखो, gas to liquid transition, एंड्रूज आइसोथर्म में हमने ये सब बोला था. But this is not something that usually happens. ठीक है, इसलिए मैं इसको इरेज कर रहा हूँ. ये चीज़ वो एक्सेप्शनल चीज़ थी, वो हम लोग जो बात कर रहे थे. So that was an exceptional thing. ठीक है. I won't spend too much time on this because this is a theoretical debate and none of you are actually asking me the question. But I feel like I should, I should tell you what's happening. तो इसलिए मैं सोचा आपको बता दूँ. अगर कोई डाउट है तो पूछ लो, I'm here. Otherwise we'll move on. ठीक है. Moles. moles कहाँ जाएंगे? Intensive. I'm going to just put moles on extensive here. We have done this, right? Volume. Ashutosh, is that your hand as a hand raise, or are you giving me a 5? Here's a, oh wait, mirror image. There you go. There's a 5. Moles is extensive. We'll move on, right? Moles volume are extensive. हमने DRAM में देखा ही था. Density is intensive. ये भी मैंने आपको पिछले वाले में बता दिया था. ठीक है? I think I'm covering this a little bit. But yeah, density is intensive. Why? Because this is a property of the substance itself, right? Think of liquid now. Don't think of gas. Easy to understand liquid. ठीक है. Mass is definitely extensive. Okay? Because moles is extensive, mass तो है. Definition of extensive is itself based on this. We good here? I kind of brushed through these two because हम लोग already पहले देख चुके हैं. These three in fact. We just saw that in the question before. This was an interesting one. I hope you guys have followed this. ठीक है. The ratio of two extensive properties is most likely going to be an intensive property. ठीक है? Hence, this right here. Okay, quick question. Which of the following is an intensive property? I'm waiting for inputs now. A, B, C or D. Okay. Asya, Sridula, Medha, Deepanvita, and temperature by Ashutosh sealing the deal. 5 for temperature, we move on. Deepu, excellent. Yes, straightforward one. Awesome. Milendra also saying it. Okay, let's talk about what exactly is thermodynamic equilibrium. Well, when things don't change with time, okay, things do not change with time, then you say that equilibrium is attained. Now, at equilibrium, all properties, all macroscopic observable properties are constant. Yes, Lakshya, absolutely right. Deepu and Milendra, all of you are right. Pranjal, you're right as well. I think it's possible कि आप लोग जो देख रहे हैं वो 30 seconds or so is behind what I'm saying, but that's all right. ठीक है? And any process that leads to that equilibrium condition is called a thermodynamic process. मतलब कि, okay, I'm changing the state from one equilibrium to another equilibrium. ठीक है, थोड़ा सा थियोरी है, अगर डाउट है तो पूछ लीजिए, but this is what I'm defining thermodynamic equilibrium as, thermodynamic process as. Because what I'm going to do next is I'm going to talk about 4 or 5 thermodynamic processes. 4 of them right now. Isothermal, adiabatic, isobaric, isochoric. Now out of these 4, 3 तो आपको मालूम है ऑलरेडी. Isothermal मतलब constant T. Isobaric मतलब constant pressure. Isochoric मतलब क्या? आशुतोष, मे बी यू मिस द लास्ट 10 minutes, बट हम लोग उसी को डिटेल में इंटेंसिव प्रॉपर्टी बोल रहे थे. स्टफ दैट डजंट डिपेंड ऑन द मास ऑफ अ सिस्टम. ओके, जस्ट रीवॉच द लास्ट 10 minutes एंड हम लोग बहुत डिटेल में उसको किया है. यस, मेधा, कांस्टेंट वॉल्यूम, गुड जॉब. अडायाबैटिक मतलब कांस्टेंट हीट. व्हाट इज कांस्टेंट हीट, हम लोग उसको देखते हैं डिटेल. तो यू नो, थिंक अबाउट इट लाइक दिस. आरंट दीज डिफरेंट पाथ्स? आइसोथर्मल इज सेइंग कि अच्छा, मैंने एक चीज फिक्स कर दी और हम लोग इसी पाथ से वहां पे जाएंगे. दैट्स व्हाट वी आर सेइंग. एंड अडायाबैटिक इज आल्सो अ पाथ, आइसोबारिक इज आल्सो अ पाथ, एंड सो इज आइसोकोरिक. ये समझ में आ रहा है थोड़ा सा? अगर मैंने कोई चीज फिक्स कर दी, मैं बोल रहा हूं कि हम इसी डायरेक्शन से जाएंगे. नॉट डायरेक्शन, बिकॉज डायरेक्शन नॉर्थ साउथ ईस्ट वेस्ट, बट हम लोग एक कंडीशन डिफाइन कर रहे हैं. अगर हम लोग एक कंडीशन डिफाइन करते हैं तो हमने पाथ डिफाइन कर दिया है. या take that as a statement of fact, अगर थोड़ा रैंडम लग रहा है, but it's very important that these are different paths. ठीक है, of getting to the same state. It's possible that I can get to the same temperature using an isobaric process or an isochoric process, but दोनों में कुछ चीजें अलग होंगी, कुछ चीजें सेम होंगी. इससे बोल रहा हूं कि ये सब अलग paths हैं. State function remain the same, but paths functions जो हैं उनकी वैल्यू अलग हो जाएगी. Isothermal process क्या होता है? ये आपको याद है, PV equal to constant, है ना? ये हमने देखा था फ्रॉम गेस स्टेट्स ऑफ मैटर, gaseous state and all of that, Boyle's law. Anyway, so here you go. It doesn't always have to be with gases, right? I could just do this. When there's a change happening of state, मतलब कि solid is becoming liquid, at 0 degrees Celsius, all the heat from the atmosphere is absorbed to break those amazing solid lattice bonds or whatever you want to call them, and then give away liquid, right? So this is the best example of a non-gas where temperature is constant. ठीक है? Yeah. Ashutosh, isothermal is not uniform heat. Isothermal is uniform temperature. ठीक है? Heat और temperature में बहुत बड़ा फर्क होता है. ये मैंने states of matter में बताया था डिटेल में, but heat flows from a higher temperature to a lower temperature. You are stealing my lines. ये मैं आगे बताने वाला था. ठीक है, we'll talk about heat in just a minute. Not 1 minute. Let's say proverbial 1 minute, which is 10 minutes. 10 मिनट के बाद हम लोग heat की बात करेंगे. ठीक है. Adiabatic process. Shridula ji, you had asked me what is an adiabatic process. This is where heat transferred is 0. I've written some weird thing. I've written dq is equal to 0. पुराने वाले भी मैंने लिखा था dt is equal to 0. ये d क्या है? देखो, डेल्टा टी तो आपको समझ में आता है, मतलब कि टी एफ माइनस टी आई इज इक्वल टू 0, यानी कि टी एफ इक्वल टू टी आई. अब ये छोटा डी वो क्या मतलब है? दिस स्मॉल डी ओवर हियर इज जस्ट सेइंग दैट दिस इज अ कैलकुलस का आइडिया. आई नो दैट अ लॉट ऑफ यू आर नॉट वेरी फॉन्ड ऑफ मैथ्स, बट फिजिक्स में थोड़ा बहुत तो कैलकुलस लगता है, स्पेशली 12th ग्रेड में, और केमिस्ट्री में तो नील बराबर रखता है, but more to understand how things work. Okay, when you make very very small changes, then you put this small d right next to it. ठीक है? So what I'm trying to say is कि even at the smallest case there is no change. Okay, so I'm saying that there is no change in heat. यानी कि वो याद आया, thermos, right? So if I have an adiabatic boundary, then I can force this sort of process to happen. मतलब मैं एक ऐसी बाउंड्री लेता हूं कि मैं हीट ट्रांसफर होने ही नहीं देता हूं. If I do not let heat transfer happen, then that process is called adiabatic. Okay? Cool? Yes, absolutely right, Deepanvita and Ashutosh. Any doubts on adiabatic? Shridula, we good? Everybody else here good with what is an adiabatic process? Here is a beautiful example of the flask that I just showed you, like cross section and all. Isobaric process, isochoric what I was going to say, is pressures doesn't change. Pressure कैसे नहीं बदलता है? Pressure Oh, if you do something open to, hey Bharadwaj ji, Milendra, using the same lingo as Naruto, I like it. Okay. Pressure क्यों नहीं बदलेगा? If I do things open to the atmosphere, then atmospheric pressure है वो तो constant रहता है. And a lot of reactions that happen in the lab happen at a constant atmospheric pressure, यानी कि pressure नहीं बदलता है. Hence, those are all isobaric processes. सोचिए, अभी आप आराम से सुनिए like a कहानी, but ये बहुत जरूरी बातें आपको बता रहा हूँ, ठीक है? Isobaric process मतलब कि maybe it could be an example is when you're doing things at atmospheric pressure. ठीक है, atmospheric pressure बहुत ज्यादा होता है यार, लगता है कुछ नहीं है, आप खेल रहे हो कूद रहे हो, but it's a huge amount of pressure. ठीक है. Isochoric, simple, constant volume कहाँ पे? Pressure cooker. This is like a simple example. ठीक है? All right, cool. So all of these processes are based on the different, ways that you're carrying it out. Ways मतलब basically is what I call the path. And we saw, what did we see? We saw dq equal to 0, dv equal to 0, dp equal to 0. और कौन सा था? चौथा भी था ना एक और, कौन सा था? Isochoric, isobaric, isothermal. हाँ, dt equal to 0. ये चार थे. अब हम लोग दो और पाथ बोल रहे हैं, ठीक है? अब मैं इसको रिवर्सिबली कर सकता हूँ या इरिवर्सिबली कर सकता हूँ. अब इन दोनों में से समझने के लिए dt, थैंक यू मेधा एंड दीपाना, थैंक यू फॉर दैट. अब इन दोनों को समझने के लिए सबसे आसान है ये वाला. Because mostly nature में stuff around you is irreversible, so to speak. मतलब देखो, मैंने एक ईंट का पीस रख दिया इसके ऊपर और ईंट का पीस हटा दिया. ईंट का पीस जैसे ही रखा वो तुरंत एक शॉट में अंदर नीचे चला जाता है, हटाया तुरंत वापस आ जाता है. This is just like that piston. What am I doing by putting that brick on top? By putting that brick on top, I'm increasing the weight. By increasing the weight, I'm increasing the pressure. So I'm putting some extra pressure on top of this. How am I increasing the pressure? Pressure is force by area. What is force? mg. ठीक है? तो this weight here is basically that extra weight I'm putting on top. तो मैंने जैसे ही वो ब्रेक वहां पे ऊपर डाला, just goes in. One shot. जैसे निकाला, वापस बाहर आ गया. Why is this irreversible? अगर से मैं हटाता नहीं, if I don't take that brick off, if I leave it there, then वो हो गया तो हो गया भाई, खत्म हो गया. It's not going to come back up on its own. Hence irreversible. ठीक है? हाँ, फिर बट इफ आई एम कॉलिंग इट इरिवर्सिबल और मैंने उसको वापस उठा लिया, लुक्स लाइक इट्स रिवर्सिबल. ये इसीलिए है बिकॉज दिस इज अ थियोरेटिकल केस. रियलिटी में अगर एक रिएक्शन एक डायरेक्शन में चला गया तो वापस कभी नहीं आने वाला है, इन थियोरी. यस आशुतोष, एब्सोल्युटली राइट. ठीक है, we'll talk about this irreversible thing in detail in the next session and we'll relate it to the idea of work. But for now, this is a real process and it takes finite time, मतलब तुरंत हो जाता है. And the driving force is much greater than the opposing force. मतलब opposing force क्या है? ऊपर जाना क्यों आएगा? Because maybe the piston is my atmospheric pressure and all. ऊपर से मैं weight डाल रहा हूँ, थप नीचे चला गया. Okay, so this is just some theory on NCERT. Please try and remember it, make notes about it, etc., etc. And this thermodynamic equilibrium is there only initially. मतलब पहले जब वो ब्रेक नहीं था, that is my first state. And the second state is when the brake is put and all the weight goes to the नीचे. ये बीच वाला step जब वो नीचे जा रहा है, that is not equilibrium. Okay, equilibrium occurs when it has reached the final state. So there's initial state, final state. दो अलग-अलग clear states हैं. ठीक है? बीच वाले stages के बारे में we can't really talk about it because it happens so quickly in case of a irreversible process. Okay. Now सेम चीज फिर से रखी है. एंड अगर मैं इसको हटाऊं तो इट डज नॉट रिस्टोर द सिस्टम एंड सराउंडिंग बैक टू ओरिजिनल स्टेट. ये वाला पार्ट ना, दिस सेकंड स्टेटमेंट आई हैव रिटन ओवर हियर विल बी क्लियर इन आई थिंक इन सेशन 6 or 5, 6 or 5, most likely in 6 actually, session 6, when we talk about what is entropy. ठीक है, दैट्स व्हाट इट मींस बाय इट डज नॉट रिस्टोर सिस्टम एंड सराउंडिंग. ये तो बहुत फैंसी है. सराउंडिंग कहां से आ गया? अभी हम लोग सिस्टम के भी तो बात कर रहे थे. सराउंडिंग, या व्हेन यू डू एन इरिवर्सिबल थिंग, इट बेसिकली messes up everything. Not mess up, it changes everything for good. You can't change it back. ये step I understand. The last thing may be a little abstract and thermodynamics है थोड़ी abstract. I will try and help you through it, but please read the NCERT. That's your best bet. इसके बारे में if you want to know what this is, it has to do with entropy. Let's talk about a reversible process. And this is a beautiful way of imagining it. Say instead of putting like huge brick, I'm taking that same brick and I'm मैं उस brick को बहुत छोटे-छोटे pieces में crush कर रहा हूँ. Not with my hand. Finite steps मतलब मैंने बताया ना कि एक स्टेप की ये डाला, दूसरे स्टेप ये. अब ये देखो, I'll tell you how to understand finite steps. Look at infinite steps. This doesn't just look at infinite steps. I literally take sand, थोड़ा थोड़ा sand में डालता जा रहा हूँ और infinite number of sand particles are there. So theoretically it's like an infinite number of steps. It's not in one step. ये धीरे धीरे आराम से होता रहता है. और similarly उसको हटाना हो तो मैं वैक्यूम से, very slow vacuum से धीरे धीरे एक एक sand के पीस हटाता जाता हूँ. So you understand Sridhara how this is infinite steps? Theoretically infinite मतलब ठीक है 100 step, 1000 step. और वो क्या था, मैंने एक स्टेप में कर दिया. फाइनाइट मतलब कि एक ब्रिक डाला, दब से नीचे गया. कूल. ओके, सो दिस इज अ ब्यूटीफुल एनिमेशन टू डिस्क्राइब व्हाट अ रिवर्सिबल प्रोसेस. तो मैं धीरे धीरे मास इंक्रीज करता जा रहा हूं. तो इट वाज m, देन इट वाज m प्लस dp, होल्ड ऑन, ऐसे इज m, देन m प्लस dm, देन m प्लस 2dm प्लस m प्लस 3dm एटसेट्रा. मतलब dm मतलब बहुत छोटा छोटा. तो मैं धीरे धीरे मास इंक्रीज करता जाता हूं. So this is a reversible process, okay? It's an ideal process, takes infinite time because बहुत धीरे धीरे होता रहता है और driving force is so small that it almost feel like there is no driving force. बहुत धीरे धीरे बढ़ता रहता है, ठीक है? And this is always in thermodynamic equilibrium every stage of the process. Because ये changes बहुत कम है, ये वाले, तो you can say that these both are almost equal. And hence these both are almost equal. These both are almost equal. अब ये बोलोगे यार हर स्टेप ऑलमोस्ट इक्वल है तो हो ही क्यों रहा है? दैट्स अ थिंग, राइट? हेंस इट्स अ थियोरेटिकल आइडिया. इतना मैथमेटिकल जगलरी हम लोग क्यों कर रहे हैं, इतना थियोरी क्यों कर रहे हैं? बिकॉज दिस विल हेल्प अस गेट टू द आइडियल स्टेट. वंस वी नो व्हाट द आइडियल स्टेट इज, देन वी विल ट्राई एंड अचीव इट ना. इफ यू आर आस्किंग मी भाई क्यों कर रहे हो सब, ये जो कभी होता ही नहीं है, देन यू नो द लिमिट ऑफ योर मशीन. The whole goal is to make some sort of a contraption, to make something out of this, to extract work out of it. If you get the ideal amount of work to be extracted or heat to be, gotten out of it, then you can say that, if we get close to this number, we'll be good. That's what we're trying to do. ठीक है? Okay. Great. Very, very slow. A series of equilibrium state. वो धीरे धीरे जो sand आता रहता, those are the different equilibrium states. एंड आई कैन रिवर्स इट एट एनी पॉइंट टाइम. मतलब मैं एक पीस सैंड हमेशा निकाल सकता हूँ, एक पीस निकाल कभी भी बीच में निकाल सकता हूँ थोड़ा, बिकॉज सिंस अ वेरी स्मॉल चेंज एंड द सिस्टम एंड सराउंडिंग्स कैन बी रिस्टोर्ड बैक टू द ओरिजिनल स्टेट. अगेन ये वाला पार्ट सेशन 6 में क्लियर होगा. अभी इट्स अ लिटिल रैंडम टू टॉक अबाउट, बट सिंस इज इन एनसीईआरटी आई एम टॉकिंग अबाउट राइट नाउ. आशुतोष, लंबा सा कमेंट, लेट मी ट्राई एंड रीड इट. इन रिवर्सिबल प्रोसेस यू पुट ब्रेक फॉर प्रेशर, रिमूव इट. So, वो रिमूव करने वाला है, वो जस्ट शोइंग कि वो भी तुरंत वापस ऊपर आ जाता है. ठीक है? सो द वे इट्स इरिवर्सिबल इज कि इफ आई पुट द ब्रिक इट गोज डाउन, इफ आई लीव द ब्रिक देयर यू आर डन. दैट वाज प्रोसेस 1. प्रोसेस 2 इज कि ब्रिक वाज ऑलरेडी देयर और मैं हटा देता हूं. दिस सेकंड प्रोसेस इज आल्सो इरिवर्सिबल. ऊपर चला गया तो कभी वापस नहीं आएगा अनलेस आई पुट दैट ब्रिक देयर. ठीक है? मे बी इट गॉट आशुतोष वाज कंफ्यूजिंग क्योंकि मैं ब्रिक को डाल रहा था और हटा रहा था. बट आप डालने और हटाने को take them as two separate processes. Just like putting a few drops of sand, take that as one process. You keep doing it, it's very, very, very slow, infinite steps. Then you keep taking out, that's a separate process. ये दोनों steps, दोनों processes अलग-अलग हैं, and both of them have infinite and all of that. Does that clear your doubt? So how is it reverse and irreversible? Removed, irreversible, powder removed. Did you understand what I just said? Here's an example of a reversible process, very simple one. Ice melting to water and back. Ashutosh, if you have doubts, please ask me. Here it is again, just putting everything in perspective. कि देखो अगर final position वही है, that's why I said कि इसको अलग अलग करो. Talk about only compression and or only expansion, one at a time. So if we talk about in this case only expansion, हम लोग अब सिर्फ expansion. That's a great question actually, Ashutosh. We are only comparing expansion for reversible and irreversible, right? So ये क्या है? ये वाला होगा reversible, ये होगा irreversible. Irreversible में that brick we just remove. So up it goes, okay? So it's one step. In this हम लोग धीरे धीरे प्रेशर कम करते रहते हैं. We keep taking vacuum से हम लोग थोड़ा थोड़ा हटाते रहते हैं. So these are intermediate positions and this happens, in infinite steps, etc., etc., and all those steps are in equilibrium. Any doubts so far? Are we doing good? Alive and kicking? Everyone's all right? Okay, cool. So, natural process, as I told you, Okay, Milendra, Medha, great Lakshya. Good to know you're figuring it out, Deepanvita. Ashutosh ji, please, पूछिए सवाल, don't worry. It's okay if you feel that मेरा doubt basic है or anything, it doesn't matter. हम लोग क्लास में हैं, सीख के जाएंगे, ठीक है? Most natural processes are irreversible. ये मैं आपको बता चुका हूँ, ठीक है? पानी ऊपर जा रहा है तो वापस नहीं आएगा unless बारिश हो. That's a different thing altogether. ठीक है? Okay, here's a question. Gaseous system shows pressure P1, volume V1 and temperature T1. It has undergone thermodynamic changes where temperature is remaining constant. Then the process is simple सवाल. Pranjal ji, good to know you've understood. Adiabat, isothermal, isobaric, isochoric. Definition ही पूछ रहा हूँ मैं आप लोगों से और कुछ नहीं. Good. Everyone's been paying attention. Medha, Shidula, Deepanvita, Milendra, Asya, Captain Lucky. Oh, 3, 4, 5, 6 ज़्यादा हो गया ना. I forget to scratch it out. Okay, we have lift off, 6 people and more. Going on and on and on. Lakshya also. Isothermal, Deepu, everyone's saying isothermal. Good job. How about this one? Here's a description on top of my head right now. 2 types of systems A and B are given below. They are open closed, isolated closed, adiabat isolated, closed or isolated. और ये बोल रहा है कि मैटर नहीं जाएगा, एनर्जी जाएगी. ये बोल रहा है कि मैटर नहीं जाएगा, एनर्जी भी नहीं जाएगी. कोई कॉन्स्पिरेसी थ्योरी नहीं बोल रहा है अभी कि सब आंसर बी आ रहे हैं. नहीं, बट समवन सेइंग डी आल्सो. सो दीपू एंड प्रांजल आर सेइंग बी, whereas Asya, Shridula, Milendra and Deepu have changed their answer. अरे दल बदलू. Good job to Deepu's D, and so is Medha and Anonymous. We have hackers among us. Anonymous has also said D. That pushes us over the edge. Oh, okay. Deepanvita is saying C. ठीक है. Deepanvita, I think what happened there was कि मैं बोल रहा हूँ कि एनर्जी ट्रांसफर हो सकती है. अगर एनर्जी ट्रांसफर हो सकती है तो एडाबैट नहीं होगा. ठीक है. मैटर नहीं हो सकता है मतलब क्लोज है. पहला वाला तो डेफिनेटली क्लोज है. आउट ऑफ दीज ऑप्शन ओनली द लास्ट ऑप्शन इज क्लोज. तो सिंपल है, यही आंसर. आइसोलेट मतलब दोनों नहीं होगी. ठीक है. सो इन न्यूमेरिकल्स, hack your way through. I've told you there are 2 ways to all of this, right? Learning and your game phase. Like learning is हम लोग आराम से सीखेंगे, and when you got a test, you got to get the answer. Okay, this is a way to do this one. ये वाला आसान है कि देखो एनर्जी होती है और मैटर नहीं होता है. मैटर नहीं होता है तो डेफिनेटली क्लोज्ड या आइसोलेटेड है. बट इट्स नॉट आइसोलेटेड बिकॉज एनर्जी जा सकती है, hence it must be closed and only one answer is there. Cool? Okay. किसी ने उल्टा बोल दिया था. I'm giving them the benefit of doubt saying कि maybe आपने ठीक से पढ़ा नहीं, but yeah, sure. Okay. Sweet. That brings us to the last part of this session, which is internal energy. Beautiful idea. Now, everything has some sort of energy stored in it. Now, there's no way for us to store, to measure that energy, but we can measure the change in energy. Now, this idea blows my mind. Ki you have no way of knowing what energy something is at, but you can measure if that energy changes. Okay, why? Because when there's a change in energy, it changes the form to something else. What am I talking about? Firstly, internal energy is the quantity of matter has some sort of definite amount of energy called internal energy. This is a definition, okay? Internal energy इतने टाइप की होती है. Translational, rotational, vibrational, electric, nuclear, bonding, 100 other things. But we're going to look at maybe translational kinetic energy. That's one. And bonding, which will lead to delta H and all that. Mainly we'll talk about these things. Okay. So I can also talk about internal energy in terms of all of these things right here, right? All of these things. But when internal energy changes, this could change to this, that could change to this could change to that, this could change to this, whatever. Because there is a change happening, I can observe that change and I can measure it. Once we do that, we can extract work out of it, we can extract heat out of it. Why am I talking only about heat and work? Because that's essentially all you're doing. When you're burning coal, right? आप क्या कर रहे हो? Coal burn कर रहे हो, उससे गर्मी निकल रही है, गर्मी से पानी उबलता है, पानी उबलने से you get steam. From steam you move around turbines. From that you get electricity, and that's how you're able to see me on whatever device you see me on. Mostly, right? In India, I think coal, maybe some nuclear power is also there. I'll repeat that in English. Coal burns, produces heat that forms steam from water. That steam turns turbines. Turbines create electricity. Goes to your house, and you're able to see me based on that. So all these are different forms of energy changes, right? So I'm extracting heat and work out of it. Everything can be mainly you can pinpoint it on these 2 things. इसलिए हम लोग इसकी बात करने वाले in terms of internal energy at our level. Cool. Carbon release. Okay, delta U. So या सो दिस इंटरनल चेंज कैन बी जीरो, पॉजिटिव और नेगेटिव. अब ये पॉजिटिव और नेगेटिव का क्या मतलब है? देखो, पॉजिटिव और नेगेटिव हियर इज लाइक बैंक में पैसा डालना और बैंक में पैसा निकालना. दिस इज नॉट अबाउट वेक्टर क्वांटिटी, ठीक है, नॉट साइन एंड डायरेक्शन, इट्स नॉट दैट. दिस इज नॉट दैट, ठीक है. वर्क इज स्केलर, सो इज ऑल ऑफ दिस. सो यहाँ पे अगर फिजिक्स का कोई है जो सोच रहा है ये डायरेक्शन एक्शन, इधर डायरेक्शन नहीं है, ठीक है. थिंक अबाउट दिस एज बैंक में पैसा आया तो पॉजिटिव, बैंक से पैसा गया तो नेगेटिव. दैट्स हाउ आई वुड वांट यू टू थिंक अबाउट. Endo or exo is a good way of saying Medha. We'll talk about that when we talk about enthalpy. But right now, I'm talking about internal energy. For gases, internal energy is only a function of temperature. यानी कि अगर टेम्परेचर बढ़ा तो इंटरनल एनर्जी बढ़ी, टेम्परेचर घटा तो इंटरनल एनर्जी कम हुई. Think about it that way. As I told you, I want to talk about mainly heat and work. Now, what exactly is work? Okay. Now, say I've got this nice bottle over here, water in a thermos flask. मैंने ये example इसलिए क्योंकि I always have a thermos flask with me. Adiabatic boundary. मैं शुरू में से बोला बाउंड्री, पे अटेंशन टू बाउंड्री, नो हीट ट्रांसफर. नाउ देयर आर टू सिनेरियोज. आई कैन ईदर लाइक लिटरली जस्ट कीप शेकिंग इट, दैट्स नॉट गोइंग टू वर्क. लाइक मे बी फॉर लाइक 2 hours I'm going to have to shake it and maybe it'll get hot, maybe, I don't know if that's going to work. That's a very bad idea. Or I can just take a paddle inside it and just keep stirring it. Maybe it'll get heated up. Or this is the smarter way. This is how I do it. मैं पानी लेके जाता हूँ. I go to the nice electric kettle I have downstairs on the second floor. I heat it up. Or the thing is, I get it to that same temperature. So I have done 2 different ways. So there are 2 different paths. This is path 1. This is path 2 of doing work. But I've got to the same state. What is that same state? Same final temperature. Okay. So I can say that, delta U is equal to work adiabatic. Adiabatic क्यों? क्योंकि मैंने बाउंड्रीज यहाँ की डिफाइन किया है. ये उस टाइप का वर्क है जहां पे मैं हीट ट्रांसफर नहीं होने दे रहा हूं बिटवीन सिस्टम एंड सराउंडिंग. सो इलेक्ट्रिसिटी से हीट होता है वो दूसरी बात है. दैट्स अ डिफरेंट थिंग. मैं पानी गर्म कर सकता हूं इलेक्ट्रिसिटी. दैट्स वेरी इंटरेस्टिंग. वेरी इंटरेस्टिंग. एग्जैक्टली आशुतोष. क्रेडिट और डेबिट. ब्यूटीफुल. डू यू गाइस अंडरस्टैंड दिस? ये आपकी एनसीईआरटी में बहुत अच्छी तरह लिखा हुआ है, बट आई वांट यू टू अंडरस्टैंड इट. समझे आप लोग? कोई डाउट है तो पूछ लो. सबसे जरूरी चीज फ्रॉम दिस चैप्टर is this basic. Any doubts? Are we good? We good? Shall we go on to the next one? I'm going to talk about heat right after this. I'll quickly repeat it. But do you notice one thing? मैंने बोला कि 2 अलग अलग path हैं. But looks like this path becomes a state function. Because delta U तो state function है. मैंने बोला delta U is work adiabatic. So maybe it's possible कि कुछ पाथ में अगर मैं कोई रिस्ट्रिक्शन लगाऊं तो वो पाथ कैन ऑल्सो बिकम अ स्टेट फंक्शन. जस्ट समथिंग टू थिंक अबाउट. नथिंग फॉर यू टू डू अभी राइट नाउ, बट जस्ट फूड फॉर थॉट. ठीक है. ओके, लेट्स टॉक अबाउट हीट. हीट क्या होती है? फ्लो ऑफ एनर्जी, ट्रांजिएंट एनर्जी फिजिक्स में पढ़ाया जाता है. फ्लो ऑफ एनर्जी फ्रॉम हाई टेम्परेचर टू लो टेम्परेचर. झरना गिरता है ऊपर से, like a big height to a low height, potential energy difference, right? Current flows from high potential to a low potential. Similarly, temperature flows from a high the bad punchline. Heat flows from high temperature to low potential, low temperature. ठीक है? That's it. And heat transfers where? Across the boundary. इसलिए मैंने वो funky thumbnail बनाया था. Everything is about the boundary. Okay? And there is a difference of टेम्परेचर बिटवीन द सिस्टम एंड सराउंडिंग. इसीलिए तो हीट फ्लो करती है. यहां पे आया आपका सराउंडिंग इन द पिक्चर. वी हैव नॉट टॉक्ड टू द सराउंडिंग्स. सिस्टम वी कीप सेइंग दैट, बट द सराउंडिंग मैटर्स बिकॉज हीट ट्रांसफर हैपेंस क्योंकि देयर इज अ डिफरेंस इन टेम्परेचर बिटवीन सिस्टम एंड सराउंडिंग. दे आर नॉट गोना आस्क दिस इन नीट, बट गुड टू नो. राइट. ओके, सो सेम चीज हम लोग करते हैं. नाउ we'll take a weird thermos or we'll take some other thing. Maybe we'll take the plastic bottle. Let's take this. This guy right here. Let's say कि इसमें से heat जा सकता. I can don't heat up sanitizer, but you can heat up sanitizer, right? So heat transfer possible है. There are work done? No, not really. Like I've kind of ये बंद है, right? Doesn't expand. It's a rigid wall. So I want to change the temperature the same amount to get to the same delta U. How will I do it? कैसे भी करूं मैं, गर्म कर दूंगा. Don't heat up a sanitizer. Maybe I'll just use a normal heater. पानी इसमें डाल के मैं कर सकता हूं, right? So I can say that delta U is equal to QW. QV. V माने कि volume constant. ठीक है? Since I'm saying there is no work done, maybe work is somehow related to volume. That's what I'm trying to get at. Gas when you talk about gases. Okay? This also is NCERT. Is an NCERT. I thought I'll mention this. Any doubts here? It looks like I can do heat transfer and I can do work, and both of these things will somehow affect the internal energy of the water inside this. So, in fact, this is what I'm trying to get to, and that's the first law itself, that a combination of both heat and work can lead to a change in internal energy, and that's what we'll talk about in the next session. Okay? Both of these are path functions, but when you take them together, you get a state function, which is internal energy. Internal energy, in fact, is a summation of heat and work. Remember, bank पैसा अंदर आता है तो good, बाहर जाता है तो bad. तो अगर heat is coming in, good. Work is being done on it, good. Work is going out, not good. Heat is going out, not good. Please पढ़ के आइए. It will be very easy for you if you read up the next part of the NCERT before the next session, which will be soon. I think Thursday ko hoga, I think most likely. I'll let you guys know. Tomorrow we'll start the metallurgy on 12th grade. Couple of homework questions. Example of extensive intensive properties. Take a screenshot. Answer this. What is the reversible process? Take a screenshot. Answer this. Homework questions. Quickly summarizing everything we've done so far. कोई doubts है तो पूछ लो दोस्तों. System surrounding boundary, right? That's what differentiates both of them. Yeah, we've done this so many times. I'm not going to talk about it too much. Just it's on your screens. Difference between state and path function also on your screen. Heat and work are the two path functions we looked at. State functions we looked at in a way this, and even internal energy. बहुत briefly. We'll talk about it more in the next session. We have not spoken enthalpy and entropy, but we will soon. Mostly we're going to focus on, intensive properties. We're mostly going to focus on extensive properties in our discussions, but sure, you need to know what intensive and extensive are. These are different thermodynamic processes. We've looked at them in detail. Irreversible and reversible processes, which are also something we're going to, do in the next episode. They're like one of those Marvel movies, right? Ki everything is going to be in the next episode or next movie. They do that a lot. Even Mission Impossible did that this time. I was so weirded out by MI7 because they did that. Okay, anyway, delta U is equal to QV, also equal to W adiabatic. And delta U is generally equal to Q plus W. हम लोग उसको detail में करेंगे. Cool. That's it from me. Any doubts? Any questions? Yeah? So I'm just going to leave you with the... Hey, that's awesome, Lakshya. So nice of you to say that. I'm glad that this is helping you out. So some fun things, some behind the scenes stuff. Since you guys like the thumbnail, I thought I'll tell you how we made it. So yeah, I'm not a great artist. This is what I made. And I told our great artist, okay, look, this is what I want to do. And she asked me, what does this mean? So I had to explain to her what system surrounding and boundary is, and it was awesome because she understood it. I'm like, okay, great. So you're all going to understand as well. So she understood this. She said she's going to watch this. I hope she does. This awesome artist is called Sharvari. She's a part of our team, and she made this really cool thumbnail. Okay, all right. Yeah, good to know. It was fun teaching all of you. I'll see you around tomorrow. Yeah, bye bye.